Alright, so here's the third example. We're going to find the arc length of a curve. So if we have a function and its derivative is continuous on AB, then the length of the curve y equals f of x from a to b is the integral from a to b square root 1 plus the derivative squared dx. Okay. Alright, so let's go ahead and look at our third example. So it says find the length of the arc of the curve from point P to point Q. Y is the natural log cosine x, and from the point 0, 1 to pi over 3 natural log 1 half. Alright, so first thing we need the derivative to plug into the formula. So I've got y equals the natural log cosine x. I'm going to take the derivative. So the derivative is going to be, remember how to take the derivative of natural log. So cosine x, that goes in the denominator. Derivative of this goes in the numerator. So that's negative sine x. And well, this is actually what negative tangent x. There's our derivative. So let's go ahead and plug this in. So the length of our arc is the square root of 1 plus the derivative squared, so that's negative tangent x squared dx. Okay, we're in terms of x, so my limits are going to be my x values. So that's from 0 to pi over 3. So 0 to pi over 3. So let's simplify this a little. So that's 0 to pi over 3 square root 1 plus, and then this is just tangent squared x dx. Alright, so let's think real hard about our trig identities. This is going to be 0 to pi over 3 square root, and do we remember what 1 plus tangent squared is? Remember, that's the same as secant squared. Okay, 1 plus tangent squared is secant squared. That's one of your Pythagorean identities. And so we go from 0 to pi over 3, and then the square root of secant squared is secant x dx. Alright, so now we've got to integrate this. And what's the antiderivative of secant x? Well, remember, that's one of your formulas. That's natural log, absolute value, secant x plus tangent x, and that's from 0 to pi over 3. So now we evaluate this. Well, that's natural log, that is secant pi over 3. Let me write that a little better. Pi over 3 plus tangent pi over 3 minus natural log secant of 0 plus tangent of 0. Alright, so let's see what we've got here. This is the natural log secant of pi over 3. Alright, let's see if we can do that. So secant of pi over 3, that is 1 over cosine pi over 3. So that's 1 over, and what's the cosine of pi over 3? 1 half. So 1 over 1 half, that gives us 2. So that's 2 plus, and then the tangent of pi over 3. Do we remember our special angles? Tangent of pi over 3. Remember, pi over 3 is 60 degrees, so that's what? Square root of 3 minus, and that's natural log. Well, the cosine, the secant of 0, well, remember that's 1 over cosine. So cosine of 0 is 1, so that gives me 1 over 1, so that's 1 plus, and then the tangent of 0 is 0. So this is natural log 2 plus square root of 3. Alright, And really we don't need the absolute value because this is positive. We could just put the parentheses around it. All right. So this natural log of 1 plus 0, well, 1 plus 1 is 1. Natural log of 1 is, that's right, 0. That goes out. So this is our final solution. And if you wanted to, you could plug that into your calculator and give a decimal answer. But that's how you work that problem. Check out the other two examples on ArcLink. Check out my other calculus videos. I got trig, algebra, differential equations. Check all those out. Give me a like, share, and subscribe. And thanks for watching.